So we're back at it with the Cobra 134. The last video you saw how we fixed the synthesizer circuitry on this thing. The 8 and 11 megahertz oscillators were not operating, and that was resolved by rebuilding the channel selector. Although I'm very annoyed, I'm gonna have to take it apart again in order to get the numbers to align. Right now I got it on channel 10 and you can see it's off to the side. It's supposed to be right in the middle. And it's not the kind of thing where I can just pull out the knob and reinsert it in the right position. I have to actually take it apart and give it a click so that the numbers align. After we fixed the 8 and 11 megahertz oscillators, we still had the radio transmitting and receiving at the wrong frequencies. That was resolved by aligning the 8 megahertz oscillator and repairing the 11 megahertz oscillator by replacing a Zener diode that had gone open. And now it's on frequency. But we still have the problem where it's not giving out any power on transmit. Over here on the needle you can see that when I transmit it barely even moves. And over here on the watt meter I have it on calibration with the knob all the way up, and pretty much the same story here. Not even enough power to calibrate the meter. You can see it moving a little bit. So over here on the transmitter chain, there's 3 transistors. There's this buffer, there's the driver, and then there's the final output. All 3 transistors test fine, and all their voltages test fine. The voltages only show up when you're on transmit, so that tells me that the relay contacts should be okay. Although I still need to check the contact that connects the output to the antenna. So here's the transmitter chain. This is the output transistor. This is the driver transistor. All these voltages are okay. All the voltages pretty much all depend on this source right here, number 14. So I know this source is okay. Here's the buffer. That's all okay. Voltages and transistor. And over here before the buffer there's this transformer that's got this number 15 source voltage, and that's okay as well. So what I'm curious to try is lifting this capacitor right here and injecting a 27 megahertz signal on this side of it, and seeing if that way it transmits some kind of power. And if that were the case, we know that before this transistor is where the problem lies on the mixer side. So tempted to try that out. Alright, so I've already been doing quite a bit of testing, and this is what I found. This right here is C162. It's lifted on one side, and by doing that what we're doing is basically disconnecting the mixer from the rest of the transmitter strip, and the mixer is what normally makes the 27 megahertz signal to be transmitted. And so what we're going to be doing is injecting our own 27 megahertz signal and seeing what that does. The 27 megahertz signal is being generated by my signal generator up here. And when I transmit, you can see it gives me quite a bit more power than it used to give me. Right now it's giving me about half a watt, and before it was pretty much giving nothing. So there's a big difference when I bypass C162 altogether and inject the 27 megahertz directly into the transformer through this 330 picofarad capacitor, which I'm using to block any DC from going into my signal generator. So when I bypass C162 and inject directly into the transformer, I get way more power. Right now I'm getting about 2.5 watts. So that doesn't mean that C162 is bad. I already tried replacing it and it gives me the same results. The reason it reduces the signal when I connect across C162 is because it's a very small value. It's only 2 picofarads, and it reduces the signal. And but that's the only reason. So there's a bigger difference still when I skip that transformer and inject signal directly into the base of the buffer transistor. When I do that, you can see that this thing gives me pretty much the full 4 watts that the radio is supposed to give normally. And so there's that. So when I inject signal here, I get pretty much 4 watts of power like the radio should normally do. When I inject signal here, I get only about 2.5 watts of power. And you would think that this transformer is making us lose signal, and maybe that's the problem. But the thing is, I tried adjusting the transformer, and when I do that, I find that it's already peaked. If I move it anymore, it actually passes less signal through. These little capacitors right here can go bad, and so can the coils, I guess. I've only ever seen the capacitors go bad. However, if the transformer itself was bad, I don't think it would do that whole thing where it peaks, and if I move it, it reduces the signal. Basically, when I move it, it shows signs of resonance. Like, I can actually peak it and untune it. And if the transformer was bad, or the capacitor inside of there was bad, I would not expect to see, signs of resonance. I wouldn't expect it to tune at all. I would probably, at most, have to like tune the slug all the way in or all the way out to get anything through, if anything. So I think the only reason that we get less power when I inject a signal here is because the other side of the coil is connected directly to ground, which I think is attenuating a lot of my signal generator power. So what I'm going to try and do instead is inject 27 megahertz in here, where the mixer normally injects its 27 megahertz. If it goes through the chain well from this point and non-forward, it means that there's no problem with any of these stages right here, and that the problem might actually be the mixer itself. So now I'm injecting signal right at the output of where the mixer normally injects its signal, and when I do that, you can see it gives me the same kind of power, which is about 3.5 watts, as I was getting when I was injecting a signal directly into the buffer transistor. And so that would tell me that that transformer we were looking at was not the problem. So over there on the frequency counter, we can see that it's actually producing real CB radio channels. Right, so the mixer is actually giving us the right output frequency and everything, but it just doesn't seem to be giving us a strong enough signal for the transmitter chain to amplify. I also checked the incoming signals that come to the mixer. The mixer needs two signals to work. It needs a 7.8 megahertz and a 19 megahertz or 34 megahertz signal to work. Those two are arriving at the mixer, and the mixer again gives us the right output frequency, but it just doesn't seem to give us that frequency with a strong enough signal for the transmitter chain to amplify. So right now my theory is that maybe the mixer's not giving enough output signal because it's not getting enough input signal. Maybe the 7.8 or 19 megahertz signals aren't coming into the mixer strong enough. So what I'm doing right now, if you recall in the last video, we didn't do a complete alignment, and right now what I'm going to do is I'm going to align the 19 and 34 megahertz strips so that they give us the maximum output. And I'm also going to do that with the 7.8 megahertz oscillator, so it gives us the maximum amount of output. And that way we know the mixer is being fed correctly, and maybe once it's being fed correctly, it'll give us the right output, the right amount of output signal. Okay, so what I have here is an RF probe made out of some old VU meters. The only one I'm using is this one right here. And so what we're going to do is we're going to align the 19 and 7.8 signals so that they give us the maximum power output. And right here you're going to be able to see this needle moving as I tune the transformers. And I'm just going to go down the whole 19, 34, and 7.8 megahertz chain until all of them are peaked out and are giving us the maximum output. Alright, so I'm about to start tweaking this thing, and hopefully you can see the needle here moving. So it's Alright, so there I set it to the maximum output I could get it to give me. Alright, so I'm going to repeat that same procedure with the 34 megahertz chain and the 7.8 megahertz oscillator. Alright, so after a lot of dicking around with this thing, I finally got the 19 megahertz strip peaked, and I got the 7.8 megahertz oscillator peaked for maximum output. I did not do the 34 megahertz right now, but I will. When it came to peaking the 19 megahertz strip, I was a little bit afraid of touching these two right here because they're not, I don't think they're the kind of transformers that you peak for maximum output, especially this one because it's got both 8 and 11 megahertz coming into it. So what I did in order to peak these ones, I just measured the output of this one, and then I just tuned these ones, and that way I knew that if this peaked, the output of this peaked, then I was doing something right to let more 19, the final 19 megahertz mix through and not throw this off of balance. So after that, I started playing around with this one. This is a transformer that lets the 7.8 megahertz through to the mixer, and I started playing with that as well. And after that, I just did the transmitter strip, these 3 transformers over here, till I got maximum output. And after doing that, I have a lot more output power coming out of the radio than I did before. That's 2 watts of power, a little bit short of the maximum it could do. I'm wondering if maybe my power supply might be the cause that we have a little bit less output power than we should. But this thing did really well. It really woke up after that alignment, and I think that's mainly what it needed. When I transmit on lower sideband, you can see hello, 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 hello. Gives me about the same 2 watts if I scream loud enough. The thing is, on upper sideband, I still don't have anything. Hello, hello, or very little. And I think that's just because I didn't align the 34 megahertz strip. Upper sideband uses 34 megahertz for the mixer. So really glad about that. I'm wondering if maybe just the lack of power that it still has is either due to my power supply, or maybe these coils right here. Where are they? Here, and there's another one I think here. Those two might just need some adjustment as well to finally get the most out of this radio. Alright, so I tried with a different power supply to see if that would give me a bit more output power in case the radio was starving, but it didn't make a difference. So I'm going to try to adjust these 2 last coils right here. There's also the bias on the output transistors, but for that I would rather have the complete service manual. I don't know if I mentioned, but I don't have the complete service manual. That's why I had to kind of wing it with the alignment and sort of figure it out myself how to align it. And so I'm not going to do the bias because I'm afraid of toasting the transistors. Instead of what I'm going to do for now is adjust these coils, but they're full of wax. And so what I'm going to do is I'm going to use my heat gun, and I'm going to heat up the wax in there so I can stick my adjustment tool. By the way, the alignment, I didn't do it with my metal screwdriver. I made myself an alignment tool out of this brush. Alright, and after adjusting those coils, I get about a watt more of power. Hello. You can see when I talk, the power goes down because my power supply is starving. Hello. But I mean, you know, that's a lot more power than I had before. And so we're still missing a little bit more power, but I think that's just going to be, you know, I'm just going to let that be till I get the actual alignment info on this radio, and then we'll go through the alignment all over again because we still have the receiver to align and everything. So by the way, another thing I had to do was that after I went through it with the little RF probe, all the stuff that I did with the RF probe, after that I went through it again, but this time basing the adjustment off of how much output power I was getting, and I just adjusted it for maximum output power, and most of them were actually adjusted fine in accordance with the RF probe. A couple coils actually woke up more when I did it basing it off of the output power. So in those coils, I guess the RF probe threw off the adjustment. So the radio has definitely woken up from its sleep. I'm still missing about a watt of power. The maximum I get is about 3 watts. I'm not sure what the deal with that is. I think I'm going to leave it till we do the final adjustment as the service manual says. But this is AM right there. A little bit less than 3 watts. This is upper sideband. Hello, hello. Which also hits about 3 watts, and you can hear my monitor radio going. And this is lower sideband. Hello. So right now I'm on AM and I'm using that as a monitor, and this is the speaker. Hello, 1 2 1 2 1 2 1 2 1 2. Hello, hello, 1 2 3 1 2 3. So as you can see, the radio is definitely alive now. And it's definitely come back from its sleep. I think I'm going to call this fixed now. Fixed and awaiting final alignment. And we'll do that in a separate video as soon as I get the actual service manual. Thanks for watching. And I'd like to thank the guys that have been coming back to my channel. Sorry for not posting more often. And good to see you guys in my comments.